Hi everyone, I am Neil Trevitt and I work on developer ecosystems at NVIDIA and I am president of the Khronos Group. This is my third WCVRI and it's good to be here virtually, and I hope next year maybe we can all meet again in person. Today I'm going to give you the latest updates on Khronos's OpenXR open standard for portable virtual reality. It's a great time to be talking about OpenXR as it is now being widely adopted throughout the industry. And if your company is making VR hardware or developing VR software, we hope that it'll help your business too. Let's start by introducing Khronos. If you haven't come across us before, Khronos is an open standards consortium. We provide a safe place for the industry to cooperate and create interoperability standards. These standards enable applications to access the power of 3D graphics, virtual and augmented reality, and parallel computation. We are a non-profit organization, and all the standards we create are open and royalty-free for the industry to use. We have been creating open standards for 20 years and have almost 160 members that includes everyone from the largest companies down to small startups, including many companies here in China, such as Huawei, Alibaba, and others. In fact, about 30% of our membership is from Asia. Any company around the world who wishes to join Khronos is welcome to participate, to have a voice and a vote in how Khronos standards evolve. Here are some of the Khronos open standards that are most relevant to augmented and virtual reality. On the right are 3D rendering APIs, including Vulkan, OpenGL, and WebGL. On the top are 3D asset formats, including GLTF for real-time transmission of 3D scenes and objects, which is often used in AR and VR applications. On the left are APIs and languages for parallel computation, including vision processing and inferencing. And last but not least is the OpenXR API, standard for portable access to augmented and virtual reality devices. And OpenXR is the topic of my talk today. At Khronos, we mean XR to include both augmented reality and virtual reality. OpenXR defines a common API that all XR runtimes can expose to application and engine developers. This enables XR software to be written once and to run on any XR hardware that supports the OpenXR API. For the first time, XR applications don't have to be rewritten to run on each runtime in the industry. It's important to understand that OpenXR does not prevent device vendors from continuing to innovate in the design and the implementation of their hardware and their runtimes. But the industry has now agreed on how to consistently expose the capability of the XR devices and runtimes to the software developer community to avoid industry fragmentation. OpenXR is supported by almost all the leading companies involved in building AR and VR systems throughout the industry. It's interesting that as well as providing portability, OpenXR has enabled the industry to come together to share learnings from first-generation XR APIs and to collaborate to create a new generation XR API with cutting-edge capabilities and a flexible, extensible, and future-proof architecture. OpenXR is now being deployed by major device manufacturers around the world. The OpenXR 1.0 specification was publicly released in the summer of 2019, and since then, Khronos has been working hard to release the OpenXR conformance tests to enable devices to be tested to be compliant to the OpenXR specification. Additionally, the first officially conformant devices are now shipping. This includes all the Windows mixed reality headsets and HoloLens 2 from Microsoft, plus the Oculus Rift and the Oculus Quest. Oculus, in fact, has announced that developers can now submit their OpenXR apps to the Oculus Store. There are also a significant number of runtimes and devices that will soon be compliant, including SteamVR from Valve, the Vario high-resolution VR headset, and the Monado open-source OpenXR implementation from Collabora. Valve in particular have stated that all new functionality for SteamVR will be exposed in OpenXR rather than their older proprietary OpenVR API. And with version 4.2.5, the Unreal Engine from Epic has enhanced its support for OpenXR, including optimizing reprojection and rendering. And lastly, working group members, including sensor vendors such as Ultraleap and Tobii, have developed OpenXR extensions for hand and eye tracking that are already shipping on Microsoft's HoloLens 2. So let's look at some of these announcements in a little more detail. Khronos released the full OpenXR Conformance test suite into open source earlier in July. Khronos welcomes anyone implementing OpenXR to use these conformance tests at no cost to aid in their development. Khronos also released a formal OpenXR Adopters program a little later in July. This program enables OpenXR implementers to submit their conformance testing results for working group review. And if their implementation is conformant, they are enabled to use the OpenXR logo and trademark. And just as importantly, conformant implementations enjoy the protection of the Khronos IP framework, which means that no Khronos member will assert their patents against the use of your OpenXR technology. For developers, the OpenXR Adopter Program ensures consistent implementation quality and application portability across multiple XR implementations as they roll out across the industry. One of the interesting things about this first wave of conformant OpenXR devices is that it includes several different form factors, including PC tethered and standalone devices, both AR and VR devices, and runtimes over both Windows and Android, demonstrating that the OpenXR architecture is fully capable of supporting a wide variety of platforms and devices. In parallel with the first OpenXR implementations being shipped, OpenXR working group members have defined cross-vendor hand and eye tracking extensions for building advanced user interfaces. The hand tracking extension defines a hand articulation model that will be consistently exposed by OpenXR implementations, enabling applications to use sophisticated hand interactions that will be portable across vendors. The hand tracking extension is already shipping on the HoloLens 2, and Ultraleap also has a developer preview. The eye tracking extension has been developed by sensor vendors including Tobii and will enable natural eye gaze interaction. And this extension is also already shipping on the HoloLens 2. So what functionality does OpenXR provide? Well, OpenXR contains everything an application needs to drive XR devices in a system, including device discovery, event processing, sensor tracking, and pose calculations on the input side, and frame display timing and composition, plus haptics control on the output side. However, OpenXR deliberately doesn't include any 3D rendering functionality, and so an OpenXR application will use a rendering API, such as Vulkan, to generate imagery. OpenXR can be used with any 3D API, but a new generation API such as Vulkan provides the high performance and low latency that are vital for a compelling XR experience. Whatever the 3D API is being used, OpenXR provides all the display parameters necessary for the application to be written to run portably on any OpenXR compliant device. Now let's look at some of the applications that are beginning to use OpenXR. In one of the first major gaming ports to OpenXR, Microsoft have announced that the new RenderDragon rendering engine for Minecraft will use OpenXR to provide VR support. This means Minecraft will be able to run on any OpenXR device. The open source community is also actively using OpenXR. Microsoft has released samples into open source to illustrate how to use OpenXR for augmented reality on HoloLens 2. Blender, the popular open source 3D authoring tool, now uses OpenXR to enable 3D artists to use virtual reality to go inside the scenes that they are creating, to inspect and build them interactively. Finally, the WebXR engine in Chromium, used to bring XR capabilities to the Chrome and Edge browsers, now uses OpenXR to access XR devices. In fact, the interaction between OpenXR and WebXR is very important for the industry. OpenXR is a native API. However, the metaverse of openly connected and searchable virtual spaces and interstitial AR experiences is likely to evolve out of the World Wide Web. And so it is critical that the industry bring accelerated XR capability to the browser. The World Wide Web Consortium, the W3C, is developing the WebXR standard to bring XR capabilities to the web stack. The good news is that Khronos is working closely with the WebXR working group to enable WebXR to effectively use OpenXR as a native portability API. This saves WebXR from having to be ported to dozens of proprietary runtime APIs and enabling XR on the web to be available on any OpenXR compliant device. In fact, since version 81, Google Chromium uses OpenXR as its default backend for WebXR, enabling the Google Chrome and Microsoft Edge browsers to already use any OpenXR compatible hardware. As well as providing application portability between different HMD devices, OpenXR can provide portability as AR and VR is deployed on new architectures, such as Cloud XR platforms. Cloud XR can use 5G, for example, to enable a lightweight AR device to send its real-time sensor data to an edge server that processes that sensor data and uses powerful GPUs to generate graphical augmentations that are much more sophisticated than could be generated on a battery-powered device and are sent back to the device for display. An OpenXR runtime can be implemented to run across both the AR device and the server, with the OpenXR API completely hiding the round trips over 5G from the application. This enables the same AR applications to run natively on an AR device or on an AR device connected to an edge server. OpenXR is gaining wide industry adoption because it's a win-win for all involved. Software developers can write an application once and deploy on multiple hardware platforms without reporting, saving time and money and reaching a much larger market. XR hardware vendors win when they expose the OpenXR APIs on their platform through accessing a large library of OpenXR compatible applications. And most importantly, end users win, as they will know that the XR applications that they want to run will be compatible with the system that they have purchased, growing customer confidence and growing the XR market for everyone. So Khronos is playing a vital industry role by providing a safe space for any interested companies to cooperate on the creation of open standards that benefit their own business and the wider industry. If your own company would like a voice and a vote in the development of OpenXR, you're welcome to join as a Khronos member. Or, if you prefer, you can simply implement OpenXR on your own hardware. You don't have to join Khronos. There are no royalties, and you can use the trademark and gain the protection of the Khronos IP framework if your implementation is officially conformant. So that's the end of my short presentation. If you think that your company could benefit from participating in Khronos to help steer the direction of OpenXR, or you want to implement OpenXR as a hardware vendor or use OpenXR as a software developer, we would love to hear from you and help in whatever way we can. If you have any questions on Khronos membership alongside our Asian and international members or using OpenXR in your products, please reach out to Dennis Fu, whose contact information is here on the screen. Dennis is the Khronos China Regional Director based in Shanghai and would be delighted to hear from you. Thank you.